M1 Maths, the Hairy Dog Theorem. There are some quite hairy theorems in mathematics, not the least of which is the Hairy Dog Theorem. This states that if you comb the hair on a dog, there must be at least one point where the hair radiates outwards, leaving the skin visible. On a real dog, of course, this point is at its nose. As with many mathematical theorems, you might think this one is marginally interesting, but totally useless. But you would be very wrong. It is crucial to the design of fusion power generators. In fusion reactors, the reacting plasma has to be kept at about 100 million degrees centigrade. At this sort of temperature, it would instantly vaporize a material container, so magnetic containment is used. The container is a 3D space which has the magnetic field lines on its surface everywhere parallel to the surface. Being parallel to the surface stops the plasma escaping. But the Hairy Dog Theorem seems to tell us that such a container cannot be built. There must be at least one place where the magnetic field is zero or perpendicular to the surface. The plasma would leak out at this point. Squirt out, in fact. Now, the hairy dog is topologically equivalent to a sphere, and the Hairy Dog Theorem applies only to such shapes. A donut has a hole through it, and so is not topologically a sphere. Consequently, the hair on a donut-shaped dog can be combed without producing a bald spot. You go up through its hole and down round its outside. In the same way, a donut-shaped magnetic fusion container can be made with the magnetic field everywhere parallel to its surface. So fusion containers are always built this way. This and other interesting mathematical snippets can be found at m1maths.com. Go to Extras for Teachers and click the yellow PD button.